Hello, everybody. Happy Thursday, Jake.
Hello, happy Thursday.
We are here for an excellent show. Tom Mueller is with us of Impulse Space now. Big week. Stuff just into space, so I'm sure you've been busy. How's everything going out there?
Good. Yeah, this is probably the most important week for us this year. In fact, in the history of my company.
Yeah, this year. Very casually.
Yeah.
Although we'll talk about this, but timeline-wise, it sounds like this was a big year from like start to finish. It's everything happened this year pretty much. So.
Yeah, it did. As you saw probably on the tweet from Impulse, we just got moved into this building and really started the design of this spacecraft. Like the real design of it just earlier this year, and here it is flying and healthy and happy and lonely.
Lonely. The destiny of every satellite.
I can't tell if that's a good or bad thing, honestly. It turns out he's really into satellite servicing, Jake. It's an announcement here. He would like all satellites to not be lonely. That's the mission.
Oh wow. Okay. All right. Good.
We saw you get a beverage out of the fridge right before we went live. What kind of fun thing did you bring?
It's a little early in the day for it, so it's a light beer. It's actually my executive assistant is originally from Argentina, so it's an Argentine beer. I wouldn't even try to pronounce that. But
Jake might have us on this.
Quilmes? Cool.
Nice.
Quilmes, yeah.
Although
I like it.
Argentinian accents are pretty...
Yeah.
They're pretty wild accents, so I might be pronouncing it wrong. Let's see.
Yeah.
What you got, Jake?
It's good. I like it.
Yeah.
Did you make anything? We're moving up the world from Argentina now to the northern end of the Yucatan Peninsula. What you got down there?
Okay. Yeah. Well, I'm having an orange day, so I got an orange shirt on and I got an orange beer. My local brewery here in Merida is clearing out their pumpkin ale.
So, nice.
I like that. Orange is my family color.
Okay, excellent.
Nice.
My dad had two orange logging trucks earlier in his career, and so it's kind of like orange. Orange is kind of like the family color.
Nice.
His call name on the CB radio was Sunkissed.
That's an excellent name. Honestly, that's up there.
Actually, and they're telling us in the chat here, it's the 1 year anniversary of Artemis 1 SLS Big Orange Rocket. So
it is. Right. Yes. Wow, I totally forgot about that.
Rocking the SLS.
I mean,
I got my orange.
Oh man, you're branded across the board. It's just a mystery that the Impulse site and all that is blue. So you're gonna have to do an update. So
yeah, rebrand.
I did not bring anything orange. I did bring. So I thought we were gonna be broadcasting on the eve of the Starship launch. So my first one was a Hail Mary, from Wissahickon Brewing Co. I brought a couple beers from places that I tend to cycle past. So I got the Hail Mary that I was drinking in the pre-show, Jake, where we settled a lot of debates. And then the second one is called Pow Juice, which is also pretty good. Hazy double IPA. This one's from the Conshohocken Brewing Company. I think this one's 9%. So back half of the show is going to have some good questions.
Yeah. Right.
What did we do pre-show, Jake? We did, maybe we can get Tom's take on this. I have a spicy space take that you might be the most qualified person that could ever comment on this. My feeling is that no one other than people like yourself who actually work on vehicles, cares about or should care about max Q. And that the last time a rocket has fallen apart at max Q was like probably the 1960s. How does that sit with you?
Yeah, I was never too worried about max Q. I know the structures guys sweated over it, and the aero guys.
Yes.
But the rocket engine doesn't care.
Yeah, right. Your end's doing fine.
We're just sad to be throttled down because we like to run at 100% thrust.
That's the most boring part of the flight for you. This is the part where you have to take it easy. Our thing's doing too good for the rest of the rocket right now. So,
when we upgraded the engine for Flight 3 of Falcon 1, that engine was designed to go on Falcon 9, and we actually had to throttle it down for the Falcon 1 structure. So it's actually running throttled, just not the smashed structure, which I thought was really cool.
All right. Well, that's the one time I would have cared about Max Q, Jake. Is if the Merlin was at the 1C, would have plowed the Falcon 1
Yeah,
right
that was
on through
the
the atmosphere.
ones.
Yeah.
Yeah, the 1C version for Falcon 1 ran it like, what was it? Like not 90. It actually stayed at sea level thrust. It had the throttle as it got into vacuum thrust. Yeah.
You were outdoing yourself there. So, let's keep talking about some of the old days, because I'd love to hear about. This is probably more recent than that, but Impulse Space. You just mentioned you got something in space right now, but we'd love to hear a little bit of the origin story of when you started thinking about this kind of idea. What were the early days, concepting this out, and why you've chosen. And maybe, I guess, for people that don't know Impulse Space, a little bit of the elevator pitch of why you've chosen what you're doing and what it is that you're doing.
Yeah. Mm-hmm. Well, it's kind of like the K2 story, that with Starship, there's going to be a lot of mass going to orbit very cheaply, and it's like storable propellants, hydrazine, and the traditional hypergol propellants just really don't make sense anymore, because they're hundreds of dollars a kilogram, and now you want to throw many tons of them. It's just, it's going to cost more to load the spacecraft than it does the flight, with propellant. And I've always thought about what bipropellant, reasonable performance propellants are out there, and it always kind of came back to night. I did a lot of work with hydrogen peroxide back in the day, and just not a big fan of it. I told somebody
I haven't heard good stories about this. So.
It's the only time I've ever seen an oxidizer tank just spontaneously explode down at our test site. And that was on the laser guys were using it. It wasn't the rocket thing. It was the laser guys were using it on one of their chemical lasers, and it just luckily it happened in the middle of the night. This stainless steel tank blew up. And we just had a lot of trouble with that stuff. And I'm just like, so it's out. And it's like nitrous and ethane. And even though the performance is a little lower, and even worse, their density is kind of low, you don't have to carry a pressurization system with them because they're self-pressurized. So it's kind of a pretty neat, moderate performance bipropellant. We're getting with this little guy, we're getting 290 seconds of ISP, which is pretty dang good for a 5-pounder.
Casually takes a rocket engine off the desk next to him. Yeah. Yeah. Audio listeners will have to reference the video feed to realize that he hooked up a rocket engine and held it in front of his face.
Go to the Twitter.
Be careful. I'm a foreigner. You might have run afoul of some laws by showing me that.
Yeah, he's a Canadian in Mexico, so watch out.
Yeah. ITAR police.
Just point it my way, not his way.
So as soon as I left SpaceX in 2020, I started, I got bored. I started messing around. I designed actually the Rigel engine, which is our 180-pound, the Mars lander engine. And I actually designed that thing and went and got it printed. I went to Morph 3D, a local company here in El Segundo, and went and got it printed and had it, was going to mess around with it. And that's when, my investor said, "Hey, you can incorporate, do something real."
No. You skipped over that part way too quick. I printed a Mars lander engine. I was gonna mess around with it. Like, what are the plans? How do you mess around with a Mars lander engine? Well, I know you live close to the desert, I guess, out there in the West Coast. But.
It's like getting back to my amateur rocket roots, but it's a big step up now that I've was 18 years at SpaceX, and 3D printing is just cheating for rocket engines, right? You could make such a great engine so fast and easily. It's the perfect solution for rocket engines, especially for the injectors or turbopump parts, or just about anything that's small enough to print. And so this was the first one that I personally myself designed for 3D printing. We had like the Super Draco engine and some other ones. Certainly a lot of Raptor was, but I didn't design those myself. I helped with the design of it, but I wasn't like on the CAD designing it myself. So this was the first one and it's really cool because instead of designing it for like a part that you can machine, you just design the fluid passages to be in what you think would be the perfect shape to get good mixing and flow and low losses and all that, and then just put some walls around it to give it to give it structure. And
Mm-hmm.
you come up with some pretty cool looking stuff. If you could see the inside of that engine, which ITAR would not let you look at the inside of that engine.
He literally means
It's
if
really
you
cool.
could, Jake. If you could ever.
Yeah. It's pretty trick inside there.
So you were just like, for fun, you were like, let me see if this, like, what this whole world's about, like printing and making this rocket engine, and then you were like,
Yeah.
I don't know, I'm gonna blow some stuff up. Like, what was the plan?
Yeah. No, I was just, gonna probably got the desert, run it like I did back in the amateur days, and maybe start a company at some point. And then Scott Nolan, who's one of the principals at Founders Fund, said, "Hey Tom, what are you doing?" And I told him about it. He said, "Are you gonna like make a real company out of this?" I go, "Oh, probably someday." And he said, "Why not now?" And I'm like, yeah, maybe I should do something. So here we are.
So it started with the Mars lander idea. That was sort of the kickstarting
it wasn't
thing,
really, no. Actually, the Mars lander came later. It was just really like, what size engine do I want to make? Like a space engine, like 200-pound-ish would be good. Actually, just I said 1-inch throat, just to draw something up, and that's kind of where it started. And it ended up being 180 pounds of thrusted vacuum. 170 pounds on Mars because there's a little bit of atmosphere there, so you have to have a smaller area ratio. But it's about 170 on Mars, 180 in vacuum. It just ended up, but it's going to be like a little satellite engine, which is what I cut my teeth on back in the early days at TRW. Was just the satellite engine. So that was the start of it. And I always wanted to do an orbital transfer vehicle because the whole plan was then, once Starship starts flying, there's potentially over 100 tons going up every flight, and it's probably not going to be just one big 100-ton payload. It's going to be lots of things, and it's like they need to be moved around to where they really want to go. Like we always say, it's like the container ship coming into port. There's everything on it needs to go somewhere else. It's almost like that. Mm-hmm. And so we're going to be the semi-trailer to move them off the container ship. And that's and we're not the only one doing that. It's an addressable market, so it's like something to start out with.
Yeah. I mean, we just saw that. Where was that stat? I don't know. It was on Twitter or some. I don't know if it was SpaceX themselves that had posted it or some fan had made it. But it was like, here's the summary of Transporter, and it was like 789 satellites they've already put into space. And it's like you look at something like that, and that really like highlights the whole business case. It's like this is why your company makes sense, right? Because it's like, look at how many satellites are suddenly going up, and those aren't like those aren't like necessarily Starlinks. I don't think those are like customer payloads, right? So like that's pretty wild. Right?
It had 9 launches. Yeah, there's been 9 launches, and it's like up until recently, like half of the active satellites in orbit. Like exclude Starlink. There's only, I don't know, we're still around like the 2,500 mark of non-Starlink satellites active in orbit.
Yeah.
So it's like
in history, right?
Right. Like, yeah.
Yeah. Right.
So how do you, when you kind of settled on the idea of the orbital transfer vehicle, were there certain decisions about the architecture there, or some of the technical specifics that you had decided, we're going to take this path, whereas all the others in the industry have taken this path? Anything specific like that you were kind of shading as your expertise?
There's quite a bit of competition into space, but most people are keeping it pretty small and going after CubeSats. So we just said we're going to go. It was easy to design because it's just like, let's max out the capability of one of those lower transporter spots. So it's your volume constrained and mass constrained, and how much payload can we get in there, and what kind of delta V can we, maximum amount of delta V can we give it? So you try to maximize the ISP on the engine and minimize the weight of the structure of the spacecraft, and use the volume as efficiently as you can. And so that's where Mira 1 came from.
Try to pull up some pics so we can reference them here.
It's interesting because like when we had the K2 guys on, I asked this question of like, because they're designing these enormous satellites that are kind of dependent on there being volume, like Starship sized volume, right? And right now that's
Yeah.
basically Starships. Like you're building a company around kind of like one launch vehicle. And for you, it's almost like the opposite end of the spectrum, but kind of the same idea. Like, do you think about, like, do I build this whole product line, the service offering around Falcon 9 being a present thing, right? Because that's, if you have these transporter missions and that's where all the satellites are going, and that's the only rocket that's really doing that in this volume, like, then you're building to Falcon 9 as a platform, right? Do you think about that as a company, and do you think about like how to protect yourself from the risk of, I don't know, like maybe SpaceX decides to just cancel Falcon 9 as soon as Starship's up and running, and then it's gone, right? Like,
Well, it's just because it's designed for it's designed for an ESPA ring, which are going to be around, I think, for a long time.
Okay.
I'm assuming they're going to fly them also on Starship. And our next product, Helios, is designed to go for more for Starship, like bigger stuff, much bigger stuff. So, yeah, we're future proof in our company.
Good. Yeah, no, this is like a really fascinating time for me, like in the launch market, because we spent so many years like worrying about cost of launch. Like, it's just like that, just getting off the ground was like such an important thing to figure out, and you and many others kind of solved that. Like we've hit a whole new inflection paradigm for that first stage getting to space, and now we're starting to explore like the next leg of the journey, and
not only is it much cheaper to get to space, it's so much more reliable. Think about it, like the Falcon 9 has flown like 250 times without failure now.
Yeah, it's just wild.
Incredible. And that's like 2,500 mission duty cycles of Merlin engines. It's pretty amazing.
Yeah.
So it's I tweeted that, I love to fly a Falcon 9 because you're going to get to orbit. It's like, you don't have to worry about like launch failures like you had to on past vehicles.
Yeah. Like as a platform, it's like, I mean, we will write about this in the rocket history books for a very, very long time, I think, is where Falcon 9 fits in the history of orbit. But it's just the world that's coming out of that. I mean, everybody was hoping for all these great things, but I don't know if we all kind of like really had it figured out what was going to happen. And so kind of like now seeing sort of like the stuff that's being built on top of that and where it's all kind of going. And so like, I don't think I was spending a lot of time thinking about OTVs in 2015. Like I just straight up like was not thinking of that was a huge problem to solve. Everything I was thinking about was like, if we don't get the rockets to work, then nothing else matters. Like, so whatever. And now it's like, oh, we need all this in-space propulsion. Like, okay, I didn't know that was like such an important thing, but it is. So it's, I don't know, it's kind of interesting to me as sort of like a point in history.
Yeah. I mean, the amount of the number of companies and the amount of new space designs have come that have just come forth since SpaceX got going. It's pretty cool.
Yeah.
You mentioned the scale, I think, of the lander engine, which was, now I'm blanking on the name. What was the name of it?
Rigel.
But
Rigel, which is the blue star in my favorite constellation, the Orion constellation.
And then you picked an obscure star for this other engine, which is it safe?
The small blue star next to Rigel is safe, right?
Safe, okay. I mean, it's also a good sounding rocket engine name. Like I have the safe engine,
yes.
it plays off well. Can you talk about that one a little bit too? Because people were in the chat were saying 180 pounds seems a bit much for OTV, but I think the OTV engine is a bit smaller, right?
Yeah, that the Rigel is throttleable and is great for landers. Like 4 of those happen to be perfect for the Mars lander or for a lunar lander. Or if we wanted to do something like ISS deorbit or something, like 8 of those would do it.
Hypothetically.
So
just to throw one out there. May or not mean
in case anyone is
thinking
about that.
Or if you just deorbiting capsules, you want high thrust. You want to be able to go to a pretty highly elliptical orbit and then have enough thrust that you can do it in a single burn over a short arc to hit your lips on the ground, come in steep and hit your lips on the ground. So high thrust is important in certain applications. for most, if you're just changing orbits, you don't need a lot of thrust, and then the little 5-pound safe works just great for that. This is the qual engine, so this guy was tortured pretty good. It has, I think, like almost 2 hours of runtime on it and 6,000 starts on it.
Wow. I always love looking at those, like the little engines that go on satellites. I'm like, man, there's so much
The
cool
briefcase
stuff in that.
engines.
I got
love
lots
that.
of them there, like all over my
Yeah,
desk. Here's
send me
that's
one.
got-
You know, look at my backdrop
Jesus.
here. I just got like cameras and stuff. Uh-oh, this one doesn't have a
It's got
cap,
a-
Jake.
yeah.
This one doesn't have the red anti-Jake cap on it. Cover your hand over
It's
that
got-
nozzle.
Right. It's got, aux valve, fuel valve, a sparking coil, cooling channels all printed right into it, and really nice little injector on it. We polished the inside of the nozzle to reduce heat transfer and give it higher performance. Just all the standard stuff. And it also, it has the you see when it's brand new, it has a black high emissivity paint on the nozzle, and then after we burn it for a while, it turns this ashen color, but it still has high emissivity, so it runs cooler as it radiates.
Little master's course here.
Yeah, we're gonna be way smarter at the end. This is the most we're gonna grow on it in a single podcast. 100%.
And that's Rockets 101 there.
Well, you're talking to two podcasters, so take it.
Yeah. We need Rocket 001
Yeah,
first.
we do software during the day, and then we podcast about space. So, can you talk a little bit about the mission that's ongoing? This is Leo Express 1. I don't know how much you can or can't say about what's going on with
I
it.
can. We're going to do an announcement next week. We are having some like radio problems. So we can get data down. It's hard to get data up and high speed data. So there's some config thing on the. It turns out that radios are worse than rocket science. They're like black magic.
Yeah, it's magic. Yeah.
These software configurable radios they're an analog device and they're a digital device, and you got to figure out which one is the problem. Doppler shift. I'm learning a lot. I think we're going to solve it, but we're not out of the woods yet. The great thing is we're getting data down, and we know that everything we built is working perfect. Like I remember the thermal guy was pulling his hair out because we don't have any. We haven't done any thermal testing, like just modeling, very little thermal testing. It's like, is it going to really run at this temperature? It's running exactly the temperature. It's running at 70 degrees F, like 69 degrees F. The battery's at 85. Everything's perfect. It's like the body rates are really low, which tells you like there's no propulsion leaks or anything. If you have a leak, this thing start moving. So it's just sitting up there. That's why I said it was lonely at the beginning. It's like we're not able to talk to it very well. So it's kind of like, hey guys, I'm up here. Are you gonna tell me to do something? But we're resolving it. We got a couple tests we're going to do here in the next couple days, and I think we're going to resolve it. So people have high hopes it's going to get the radio thing's going to get fixed. So that's the scoop. You guys get the scoop on what's going on with Mira.
That's great. I do want to warn you. The other scoop that we have was Jim Bridenstine telling us that Tom Cruise is flying on an Axiom flight, which never happened, and we assume he sunk the possibilities of that on our show. So I do just want a general warning that we don't have a great track record of scoop. I don't know. It hasn't happened yet.
We don't know.
These things take a while.
That's been a long time. That's been like, that was like early pandemic when he dropped that one. So.
That was DM2, yeah. So,
We'll see. It'll be a good movie if so. There was I saw at least a couple of mentions of the payload on board was from Trust. Was it Trust Point?
Trust Point, yeah. Is
that deploying or is that like a hosted payload kind of situation?
Yeah, we're going to deploy it. Mm-hmm.
Okay, cool. Nice.
Yeah.
You're doing everything at once.
It's their second CubeSat for it's sort of like a GPS type constellation with encryption. Yeah.
That's cool.
They kind of
So
have
we hope in the future to deploy their constellation. Like the Mira is set up to have multiple deployers on each side, so we can take like 32 or even maybe 48 3U CubeSats up at a time and just deploy them. So instead of waiting for them to drift into place over months, we could deploy them in like a week or two, get them all laid out.
Oh, that's cool.
Okay. Yeah, so they're right there on the side, huh?
Mm-hmm.
This thing's sweet looking. Like I'm loving the design of this situation. Cool. Yeah. I don't know, something about the fixed solar array just makes it feel like real reliable and industrial in a great way, you know.
Well, we're gonna mess that up because the version 2 of it, which is meant to go to geo, is going to have steerable, much larger deployable and steerable solar, so that we can maintain like 1 kilowatt up at geo, and radiation tolerant hardware. That's our Orbit Fab Camino design, the Vert V2 of it. So it's going to have different looking solar.
Well, I mean, it'll be doing a cooler thing, so you know.
Yeah.
And then, I mean, you've talked up like at least inner solar system work as well. Obviously, the Mars stuff we should probably talk about at some point.
Yeah.
Are there tweaks like that you're talking about with changing to solar array config or radiation hardening to get to different orbits? Are there other differences that you're thinking about with these different destinations, or do you feel like this kind of base model can take us from here to the asteroid belt or something like that?
No, so Mira can't really do, interplanetary. It can do 1 kilometer per second ish, 1.5 with like a CubeSat or two. And we could definitely make a higher delta V version of it, but we're talking maybe 2 or 3 kilometers per second limit. To get out there, we have the get there design, which is Helios, and we have the stay there design, which is Mira. So get there is Helios, which is basically a third stage for like Falcon 9 or Starship.
I love when people start talking about third stages. So that's when everything gets fun. If you've got a third stage, some shit is going down, like you're into something serious at that point.
Yeah.
I love it.
Damn.
Yeah.
Listen, I've heard some people tell me about Helios, and as much as they told me is that there's a name Helios. So
Yep. And there's a scoop. We have these flyers that are out in industry, so you might see these around. So this is what it looks like.
Look at that.
That looks like a third stage.
That's a legit third stage. Yes.
And that's like a 3-ton satellite on top or 2-ton satellite on top, and a bunch of mirrors or something like that around that Esper ring. And
loving that.
And a 20,000 pound thrust.
It's aiming a completely realistic direction away from Earth as well. I always love that about these visualizations.
Right.
Yeah. Rockets totally fly straight off of Earth. That's exactly how they go. Yeah.
That is designed to take 5 tons from LEO, from like 200, like low LEO, like 200 kilometers circular, to parked in GEO.
Damn, that's a lot.
Right now, the only thing that really can do that is a heavy,
like
heavy.
a full launch vehicle. Yeah, maximum launch vehicle right now. Yeah. Damn.
Yeah. Well, single stick Falcon 9 cannot take 4 tons to GEO. It can take the GTO, but not GEO.
And that's it.
Yeah.
And those are
heavy
like
can take.
That's probably the higher end of any GEO satellite at the moment that we know about.
Yeah, that Viasat that flew earlier this year was 6 tons, and that was what they call a triple X. That was all 3 cores expendable on a heavy. So that's how hard it is to get to GEO. But
it's pricey.
Yeah.
Staging efficiency really counts. You can have 2 more booster cores, which is kind of like a half a stage, which they weigh 1 million. They have 1 million pounds of propellant each, or you can just have a smaller upper stage and do almost the same thing with 13 tons of propellant, just much smaller.
It's wild how that math works out. That I'll never be comfortable with that math.
Listen, we already know you're a Falcon Heavy skeptic over there, Jake. All right, let's take it easy. Jake's a third stage stan and a Falcon Heavy skeptic. So
I love me that high energy stuff. That's my favorite. So.
He's just a Mars elitist. So
Yeah.
I get it.
Throw away those extra cores and give me some ion engines. Let's do this. Let's go. Let's go to Alpha Centauri. Let's do it.
So do you
Somebody
feel like the
work on that?
Yeah, that's a 4th stage at a minimum. Do you feel like the stuff that you're attracted to in this era that you're in is like parts of the tech tree that SpaceX either was actively or didn't mean to but are avoiding? Like, is that fair to say that you're taking on some things that are not on the path of where SpaceX is heading?
Yeah. SpaceX is solving, first LEO and really Mars colonization. So, the secondary transportation in space is not their focus right now.
And you're just into it because you know that it's like a thing that has to exist, or it's a really fun place to make a lot of different kinds of rocket engines?
Well, like SpaceX has solved low cost and reliable access to low Earth orbit. I want to help solve low cost, reliable access to everywhere above low Earth orbit. And Helios, anything that can get to geo can get anywhere.
Yeah.
It's actually easier to get to TLI, towards the moon, to lunar injection, that is to geo, because of that plane change you have to do. So this thing is to go anywhere in the inner solar system or outer solar system. I mean, empty this stage. Like if you just had like a half-ton satellite on it, it could do like almost 10 kilometers per second. So that can get you out to the outer planets in reasonable number of years. So it's a very capable stage. Yeah.
Wow.
This is it, Jake.
Yeah.
Going to the moons, all the moons.
I want to talk about Mars, but before we get to it, though, I just want to ask, because this like LEO satellite, like you said, you started really designing it. I think you saw the announcement or whatever, was January, and it's in space now. And I have to just ask, like, that seems pretty remarkable to me that 11 months later it's like flying. And I want to just kind of ask, like, what do you do differently, like, to make something happen that quickly? Like, turn around in a single year to put something in space seems like kind of like, why aren't more articles being written about this? I'm not really sure.
Yeah, there's companies that have went out of business quicker, like that were working on this sort of thing.
It's a couple things. We have a very experienced crew. I got a bunch of my guys that helped develop Merlin and Raptor here, and because of we have a great reputation, which we could screw up if this thing fails, but we have a great reputation, so we're able to hire. We got some real spacecraft people in here. We're great on hardware and propulsion. We're a little weak on guidance, navigation, and control, and radios, clearly. And we're learning this. I consider this our Falcon 1, and I was nervous about this thing like we were on Falcon 1, because I felt like we have a great team and we had a really nice spacecraft. I think it's a world-class little spacecraft, but you just don't know what you missed. Kind of like this radio problem, nobody saw that coming. It's like you can't test everything on the ground. Same thing as a rocket, and all the things that you missed come out. So we were just sweating it. We did this pretty fast, and we wish we had more time to test, but we're a startup. We need to get things moving. So it was pretty nerve-wracking. So I'm super happy that like I talked about earlier on, how the spacecraft seems to be in perfect shape up there, other than we can't really talk to it too well. But if we resolve that,
problem to solve for sure. Yeah.
Yeah, I think a week or two fooling around with radios we hear is pretty common on new spacecraft. So it's this is something that happens, and I have high hopes we'll resolve it. And then it's like, wow, we kind of nailed it. The spacecraft seems to be doing really well. But we still have to go up there and do some burns and stuff. So we're not out of the woods yet, even if we fix the radio. We've got to prove that everything works.
I trust your rocket engines generally.
They run great out here.
I feel like you got that part down. Yeah.
They run great out here in the vacuum chamber, but let's see how they do up there in orbit.
Let alone Mars,
Right.
Yeah. All right. Well, should we go to Mars then, or should we talk about
you've been tantrically getting closer to Mars here, so
I know. Been teasing around the edges.
We've done. Listen, he canceled his whole Mars podcast, Tom. Then we did 3 planetary science episodes in a row, and yet again, here we are, halfway through. Finally, we're talking about rockets. I'm back at my life here, and we've got to go back to Mars. So go ahead, Jake.
Yeah. No, I mean, I want to hear. So, okay, I'll admit something to you first. When we first learned about Impulse, and it was like, we're gonna build this little Mars lander, I was like, okay, whatever, guys. Like, whatever you. Here's
Have
another
you ever
Mars
heard
story.
of a 70 degrees cone, like, or whatever? What's the thing?
Yeah, you and everybody else wants to put some stupid thing on Mars. Okay, so I want to hear from you, like, like why do this? Like, what is the reason that you want to make that kind of like it's some kind of centerpiece to your company, and what do you hope to really get?
Well,
out of it?
actually,
It's kind of interesting.
It wasn't me, really. It wasn't us. It was, months after we incorporated, back in 21, that fall, my friends at Relativity came over and said, "Hey, we've got this first launch of Terran coming up. It's going to be a demo flight. We would love to do something really cool on our demo flight, like go to Mars. Would you be willing to build a spacecraft to go to Mars?" And I said, "Hell yeah." And then we started talking about, well, what are we going to do? And they said, do you think you could land something on Mars? I said, that sounds like a really good goal. Like, let's try to land something. And I immediately thought that if we're doing that, we're going to copy exactly what NASA has done on the heat shield, the shape, all that, decades of analysis they've done. The parachute
the 70-degree
design.
sphere cone, yeah.
Because
Jake,
as
your
you
camera's
guys,
out.
Yeah.
You can still hear me?
Yeah. Tom's going to keep going. You can just be a black screen.
You've got RF problems.
Yeah. This is a great Leo Express 1 demonstration you're doing. There, he's back. He's back.
Where was I?
So you were going to drive over to JPL and grift all of their designs of this.
Yeah, no, we talked with them.
And steal the 70-degree sphere cone, yeah.
Yeah.
Okay.
All that stuff is public domain, which is great. The parachute, the guys that made the parachute are still around. They're willing to make another one. Because parachutes, as you guys know, the parachutes are tricky.
Also hard, yeah.
Everybody's having trouble with parachutes. Yeah. So don't mess with once it works, don't mess with your
I just love, you're so funny because like the humanities cliche is it's not rocket science, and you're like, parachutes and radios, man, whoa, boy, like this is where the hard stuff is. Like, yes, the goat of rocket engines would say that, obviously, but everyone else in the world is like, rocket science, that's where it gets tricky.
It's the devil you don't know, right?
Yeah. Yeah. But let me tell you about the software I was debugging earlier. You would go nuts.
I know, that's a black hole for me too. So so the really unique thing about the mission is the lander. So it has we're trying to make it super mass efficient with bipropellant high performance landing engines so we can maximize the payload. So we're talking about doing a mission that can actually put more cargo on, more payload on Mars than the previous, like InSight or Phoenix, where there's the size of the vehicle that we're doing, for maybe 1/5 the cost. Like we're talking, like those missions are like $800 million. We should be able to do it for less than 200. So
you could probably charge like 400 or 500 though.
Could, yeah, probably.
I wouldn't short yourself that.
Yeah.
Personally,
the idea is to lower the cost of. Like I remember this is a great story. Early on, when we were doing Falcon 1, very early, probably within the first few years of the company. I remember we had some guys from Orbital or somewhere come in, and somebody from NASA were talking about Orbital, and they said, if you can throw the mass of a Pegasus and it costs $30 million, why aren't you charging $29 million? And Elon's answer was, we're not trying to be like the other guys. We're trying to get the cost down to the minimum. That's why it was $6 million for the Falcon 1, not $30 million. And I'm kind of the same way. It's like, I'll make a reasonable profit on this thing, but not charge the maximum I can get. So that's kind of,
you don't want to do JPL minus $1.
Yeah. Right. Yeah. That's just kind of the way I operate. I guess I learned it from Elon.
Yeah. So do you see is that more of like a thing to cut your teeth on and a cool sort of horizon goal, or do you actually think there's some sort of addressable market there for Mars in the, I don't know what time scale you're looking at, but at all really?
Yeah, no, I think if we could fly one or two of these every Mars opportunity every 2.2 years, that's reasonable income. That's we could, if we're charging 150 million with a 50% margin, like 75 million every 2 years, that's nice income. I think it's a bargain for if if we prove it, like we do the demo and it works, like this first one is just land and send back video and pictures and say I'm alive. Have radios that actually work.
Yeah, get the radios
And-
working. Yeah.
It's a good thing you got these other Leo missions first. Yeah.
Yeah, work it out.
Yeah, you don't want to duplicate Beagle 2. You want to like actually send some stuff
Right.
back. Yeah. You don't want props 50 years from now.
Yeah, and I mean, look at all of these commercial landers that have failed landing on the moon. I'm not saying it's easy, so we got to get lucky, kind of. And if we do it, then I think NASA would be willing to say we've got a little, we could take 300 kilograms to Mars. So NASA has 50 kilograms. Some university has 10 kilograms. Like we just pack a bunch of different things in there, and I think we hopefully could get a little business going. But we got to do the demo because nobody believes you can land the first time. Like I think famously the Russians have never been able to land anything. The NASA's gotten pretty good at it because they keep, they use what they've learned on the last ones, which is what we're trying to do.
Yeah. Well,
Leave some achievements for everyone else, though, Tom. If you pulled that off, it's like, oh, all right. I guess we'll all just go do something else with our life. Just land rockets on the Earth, land stuff on Mars. That's cool.
If there's anything that, I've talked about this a lot, especially when I talk to students. They ask me like, what's the most important thing that you learned? And it's be optimistic. And you can if there's anything that I really learned, being a founding member of SpaceX is it's not as hard as you think. It's, you can do it. And so don't be afraid to try hard things. Just go do it.
words of wisdom. Yeah.
Cheers.
Yeah. That's what we do. Yeah. So I'm not afraid to try and land on Mars. I would love to go to, I'm about the moon really. I think the moon is economically more important. I think scientifically Mars is very important. And I want to support that, but really, I think that the moon is super cool, and asteroids too.
Mm-hmm. Yeah. I mean, the atmosphere just gets in your way, right? So it's
Yeah.
He likes the pureness of space and rocks.
Yeah.
I mean, you can't even fly in it, like hardly at all. So it's.
I mean, he said he had to throttle down his engines to get through it. So he could go full out on the moon.
Absolutely.
Do you are in that vein though, right? We've got all these CLIPS flights coming up in the next couple of, we're like 2 months away from the first two that are going to go up.
Right.
How do you kind of, you're in a funny spot with what you just said about, you're planning for, if we can do one or two of these a Mars window, we've got a business going. And then we've got the CLIPS side of the market here that is in a funny spot, with weird dynamics of the way that these missions are bid on, kind of feeling like it's a race to the bottom on pricing, and it's putting, there's been companies going out of business in the effort, and no one's really flown yet. So it feels like that program is in a tough spot, and then who knows what's going to happen with the first couple missions. So are you watching that market and trying to figure out if it's something that Impulse would want to get involved in?
Yeah, well, I come at it differently. I wouldn't want to set up my business plan to be just a lunar lander, which some of them did, because that's difficult. Because you got to do everything for this one mission. What we have done is developed the building blocks, and I always tell my guys this. I go, we have the engines, we have the tanks, the lightweight composite wrap tanks, we have the avionics, and we're going to come up with the rad tolerant avionics, and get better at software and radios, get much better at radios, and then. So we have you go to the addressable market, which is low Earth orbit, and then you go to the market that people really want to go to, that's hard to get to, which is geo. And then once you have that, like you add to that to land on the moon. You use the same building blocks. So you already have on other programs, you have the pieces you put together to do that keep adding missions and capability.
Yeah.
So that's our
That's kind of like, what I was mentioning earlier about how we can now go to the next leg of the transportation. And it's very interesting to see, because it's not just the cost of getting to LEO that's been a game changer, but the volume of stuff we can send there, the cadence we can get means that having building blocks makes more economical sense, right? Because it's like, yeah, we'll just reassemble these and we got another thing, and there's always something going up, so we're always reassembling and blah 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 blah, right? So you can do like some pretty fancy stuff, like because like making reusable components to assemble whatever spacecraft you need didn't make sense if you were going to fly once a year and it was really expensive to do it. Like you make a bespoke special a snowflake kind of spacecraft every time when you do that, right? So
Exactly.
yeah, it was interesting. So yeah, it's again, I'm just so interested to see what sort of stuff is now bubbling to the surface now that we have like this kind of like platform available to us, right? It's kind of cool.
Yeah, I see this really now as launching off the shoulders of SpaceX. This is the true commercial exploration of space and exploitation of space. And this is said a lot, that the resources of Earth are finite. Astroforge talks about that. We're going to run out of these metals. We're going to require so much compute power that it's going to strain our resources. We need to move into space. Maybe not in the next 5 years or 10 years, but eventually. So I'm getting ready for that future, like where things need to be built in space, and then resources need to come from near Earth asteroids and the moon. And I just want to have the pieces in place when that goes.
I like how much you talk about asteroids. Nobody talks about asteroids enough, Jake. I'm an asteroid guy at this point. Like,
I can tell. Yeah.
The more these missions that go there, they're so interesting. Like they're all weird and they look strange, and nobody knows if they're solid or just rubble piles. Like there's way more intrigue there than I expected.
Yeah. But there's water, there's metals, there's there's very usable materials.
I'm not sure if you're a For All Mankind viewer though, but I mean,
I am. I love it.
They're getting into the asteroids now in season 4 here, so no spoilers.
I haven't started that. I haven't started that one yet. Yeah.
This is the asteroid one, so.
Yeah.
It's pretty legit.
Yeah,
that could be where it's at. I mean, I kind of like the moon, but somebody recently, convinced me that you got that 2.4 kilometer per second gravity well of the moon that you've got to overcome. And I always joke about that's where spin launch makes sense. That you put spin launch, you take away that that vacuum chamber and put it on the moon, and now you just throw blocks of ice or tanks of water into LEO from the moon at 2.4 kilometers per second.
This is the best show, Jake. He's verified my max Q theory, and he's just told everyone finally where spin launch is useful anywhere but Earth. Yes, right. We know you hate the atmosphere, Tom, but.
I hate the atmosphere.
The only person who hates the atmosphere worse than you is the spin launch crew.
Oh wow!
The atmosphere.
Good. Any other people out there you want to shout out as having bad ideas for Earth? That would be a great segment. Tom Mueller shouts out all the space companies that won't make it.
Did I say the bad idea? I said it's a great idea for the moon. It's a great idea.
Great idea anywhere else.
It's fair.
Honestly, that's been like the theory of spin launch. Is like, this is a good idea for something that we're not connecting on. Like, we're not. I don't know if we're communicating at the same level. Is this like a military thing? Is this like for the moon? I feel like we're not talking about the same thing. There's what was the somebody's got it. You remember the Glomar Explorer, the Howard Hughes thing that was like a cover story for actually trying to extract a submarine off the ocean floor, but it was like, no, I'm doing like deep sea mining. Like this is. The spin launch has been one that people have had the Glomar Explorer theory about, that this is like a cover for something else that's going on.
Hypersonic test rig.
Yeah, like this is just, you're making up that this is the actual mission. So I always love a Glomar Explorer theory. It's great. Yeah. It's good.
Oh, wow. Now I'm just thinking about Project HARP and how we can get that back and running again.
Oh, the space cannon? Yeah.
Yeah, the space cannon.
Yeah, not the atmospheric creating weather one, right? Because I think that was also called HARP.
Oh, was it called HARP? Yeah, no, the big gun.
Yeah, in the Barbados or whatever. There's like this old space cannon out there. Yeah. That feels like some stuff that, Tom, the next time you retire, like that, you're going to get really bored. You're going to be like, I'm going to build a space cannon. That's going to be the next thing for you.
That would work good on the
moon. If you put a space cannon on an asteroid and point it away from where you want to go, is it just propulsion? Like, it might just work that way, right?
Yeah. Look at DART,
Equal and opposite reaction.
Yeah.
Yeah.
What if you extract the useless rock out of the asteroid and then fire it away from you, and that way you are propulsing and you're also reducing the ratio of bad to good in your asteroid. By the time you get home, it's just like a big ball of
Jake,
platinum. You're set.
you just
Figure
raised
it out.
$40 million. Like, holy shit. If the Founders Fund crew is
Write that-
listening, Tom, let us know.
Write that
Okay.
one down.
The greatest theory I've ever heard. I've never heard you come up with that before. That was awesome.
That's a great one.
Yeah.
Look, a couple of
I remember-
Patito pumpkin beers, and you could be surprised at what can happen, right?
It's such a good idea. Jesus.
We used to get, we used to, especially at SpaceX, we used to get crazy letters and stuff. And this one guy sent us a paper. He was like some Italian guy and something, so there was like this language barrier. But it was called something like Boneless and Skineater, and it was a rocket that consumed itself. It was burning the metal on the rocket with oxygen, and it would just, by the time it was finished burning out, he didn't explain exactly how you're going to, powder up the structure and burn it. But anyway, it was like that one went on the wall. That was a good one.
Yeah.
And,
Did you send a letter back that was like,
Boneless and Skineater.
I'm not sure. Yeah, found the title for this show. Did you send a letter back of like, of all the companies that have burnt metal to get vertical, like, we are the company that has done that.
Oh my god.
What was there was a bunch of them. We used to have like the wall of shame, just all these different ideas and these
Spin
crazy-
launch was on there.
things.
Yeah.
There was one guy.
I
that-
can.
There was,
The letters
there
you
was
guys
spin
got, I'm
launch.
just imagining,
There was a
yeah.
Virgin Orbit one. There was let's sell Pegasus to the commercial market. It's a couple of
Right.
them that were on the wall that were actually happened.
Yeah.
Yeah.
Huh.
Oh, you're posting a link. Project Harp with 1H, Jake. I got it.
Yeah,
1H was
One
this.
A.
Yeah, yeah.
No, one A.
1H. I don't know.
Yeah, the Wikipedia literally says not to be confused with HARP, the High Frequency Active
Yeah, yeah.
Auroral Research.
That's like the
Program.
Alex Jones one. You gotta watch out. You gotta watch out. Don't get those wires crossed.
Yeah.
Tom, so you've got Leo Express 1 happening. You've got like 2 more in the pipeline. I want to hear about, like, we've talked a lot about the long distance future, but are there things we can follow along with more imminently with Impulse?
Yeah, we have Leo Express 2 on Transporter 11 next year, which is in June, I believe, of next year. So we've got payloads lined up for that.
Yes.
Can't talk about them yet. They're not signed, but they're ready to sign. And then possibly Leo Express 3, depending on the demand. I think if we really nail it on this mission, get our radios fixed and do our burns, I think hopefully we'll fill up that one too.
That's awesome. So another one by,
Yeah.
I see now it's going to be 2 spacecraft in like 18 months, and now it's an even better story.
And how many
I mean-
people is the team at this point?
Yeah.
Just over 80.
Okay. All right.
And you didn't
Nice
even
and
go
nimble
public via
still.
SPAC. Yeah. It's crazy. It's crazy.
The SPAC train's gone, Anthony. It's
Yeah?
over.
That's it? You're calling it dead?
The SPAC train crashed.
Yeah.
Left the station and got lost in the Alps somewhere.
Yeah.
Oh,
It's been,
man.
I mean, yeah. Wait, so you said this
Yeah.
is an ESPA ring. Can this, I mean, what would that fit on small launch wise? It would fit on Electron, yeah? It's kind of the only one that matters, to be real. But,
Yeah.
yeah.
It's kind of heavy for Electron's 250 kilograms, right?
They're a little higher now. They really have juiced
Yeah.
it lately, but
Okay, 300. Yeah, we're about 300. I think we're right at 300 with what's up there right now. But of course, it doesn't have very much payload on it.
it's like another kick stage.
Interesting.
Yeah.
We'd have to detank a little bit.
You're always about
But
that.
there
Throttle
you go.
down, detank, like,
I mean, the whole idea of small launches, you don't need a OTV. You go right where you want, or they'd use Photon if they want to, go a little further, or do something a little
Yeah.
different.
we got a French goodbye question in the chat, and I feel like I should bring it up. Here we are on the somewhat eve of a Starship launch. What is your opinion on hot staging? Is it gonna go chaotically wrong? Is it gonna
Is
be
it gonna
awesome?
work?
Yeah.
It's funny because I was just hanging out with a bunch of my SpaceX buddies, and some of them are working Starship. They're complaining about hot staging. You know, I used to push back on Elon too, and now that I'm the CEO, I don't like getting pushed back. It's like that's the right thing to do. Hot staging is the right thing to do, and it's like just suck it up and do it, guys. Like it's gonna work. Maybe it won't work this first time, but you'll get it working. I mean, you know, Titan did it. The Russians did it. It's if people try to figure out why you need to do it, but it's simple. If you decelerate and all the propellant comes forward and that hot ullage mixes with the cold propellant and it collapses and you've got to repress the tanks, it's just tons of lost payload. And if you hot stage, you don't go through all that. So it's like, it's the right thing to do. They need to do it. Like, suck it up and make it happen.
That's more math that I'm never comfortable with, because like they were like, some people in our Discord were doing like, you know, ideas on how big it would be, and it's like 20,000 pounds of hot stage ring you have to add in the middle there, or whatever that, you know, chunk of steel and heat shield and stuff costs. And it's like, wow, that is really that's cheaper than the all the plumbing for the ullage motors and all that kind of stuff. Like that's kind of wild to me that works out, right? Yeah, it's crazy.
And it just straight up looks cooler. I mean, come on.
Yeah. It does look cooler.
Yeah. I mean, there's other ways to do it. Like Apollo used ullage motors, but you know, there's not a lot of motors laying around that are cheap and they're hard to develop. So it's just use the motor you have, the second stage engines.
All right, you're for hot staging. What's the one thing that you're annoyed at with Starship in its current configuration?
Raptor reliability.
Okay, just right back to your old position. Yeah. You can take the man out of SpaceX.
I mean, come on, guys. The most reliable rocket engine by far in history is the Merlin. So why isn't Raptor there right there? It could be. It's not. I mean, we know there's some Raptor problems that they're working through, but I don't know if all the engines shutting off are actual Raptor problems or other things on the system getting broken.
Yeah.
You know?
I mean, have you ever blown up a launch pad into your engines, Tom? I bet you never did that.
A launch pad? No.
Plenty of other stuff. Yeah. You've done a Skineater or whatever.
I've blown up test stands, but not launch pads.
You never run a launch pad rich launch.
No. And I'm shedding the image that the first failure of Falcon 1 was me. It wasn't. It was avionics. We sat on that island for an extra 6 months because of avionics problems in an untenable corrosion environment. It just wasn't solvable. And that's why it failed, not because propulsion screwed up with the aluminum nuts.
I believe that's somewhere in this book, right? Our friend
right
Eric Berger.
Look at on the cover. That thing's on fire because of avionics.
Liftoff. Shout out Eric, because that's a great book.
I love it.
A primary source right here for most of that book,
Really
I think.
Wow. Okay. Well,
Awesome.
this has been awesome. Yeah. This is so cool. I'm really excited for you guys. I think it's really fun to see, like I said 3 or 4 times now, it's just fun to see what kind of stuff is bubbling up, and you know, Impulse is one of those things. So I hope you figure out the radios and and then you move on to the next ones, and then we'll talk again when you're on Mars.
I'll sleep a lot better when the radios are resolved.
Yeah. Well, I think follow along on Twitter or X or Instagram or something about that.
Yeah.
We've got all the links on the site, so follow along somewhere, because it's gonna be awesome.
We'll let you know. We'll let everybody know as soon as we get some good news.
Awesome. Well, thanks for hanging out with us, Jake. What are we doing on this show here next week? Oh, next week's Thanksgiving.
Well, next week is American Turkey Day, so we will not be having an episode. But the week after that, we've got a fun one. So in the pre-show, you've been harping on me to buy a telescope. And we thought, hey, what if we asked someone who knew things about telescopes what to do? And so we're going to have Andrew McCarthy come on and show us some of the cool photos he's taken and teach us about telescopes. So it should be fun. Yeah,
this guy has some crazy pictures. There's this one I will pull up real quick.
Really amazing. Yeah.
Like this shot of the moon and the ISS. It's just the most sci-fi amazing picture I've seen in my life. So
Yeah.
That's gonna
really
be
good.
awesome.
Cool. Yeah.
All right,
Well,
Tom, this has been like a highlight of our podcast for sure. Awesome to have you hang out for so long and
Thanks a lot,
give
guys.
some
It was
hot takes
fun.
about Max Q, Spin Launch, and Starship. I feel very fulfilled. So we appreciate you very much.
Thanks a lot, guys.
All right, see you later,
all right.
everybody.
See you, everybody.
Bye.
Bye.
Bye.